This is the Ultra EDI 14 electro-deionization system from Alien Technologies. It's designed to produce 14 gallons a minute of purified water, basically deionized water, approximately 15-17 megohm of resistivity. It needs to be fed with reverse osmosis permeate water, preferably less than 10 microsiemens of conductivity. Could go a little bit higher, but we recommend around 10 microsiemens. System is all skid mounted and complete, consisting of a control panel, some adjusting valves, instrumentation, and then on the back of the machine, the two electro-deionization modules. There's two modules on this system. Each one is designed to produce about 7 gallons a minute of purified water. The installation of the equipment is very simple. There's 3 connections, all on this side. Okay. The connections for installation are all here on the left side of the skid. We have 3 connections. We have a raw water inlet. Again, this should be reverse osmosis permeate water. Then we have the purified water outlet, which is a polypropylene pipe coming out, 1 inch. Both of these are 1 inch. Then we have our waste stream, which actually is 2 streams. You can see 2 tubes here. One is the electrolyte and one is the concentrate from the EDI module. This is a very small amount of waste, usually less than 10% of the total flow. So in this case, we probably have about maybe 1 to 1.5 gallons a minute from coming out of this 1/2 inch polypropylene outlet. The operation of the equipment is all via this control panel. All the switches are indicated here. I'll go through that in just a second. Here's the instruments of note. There's a number of pressure gauges that need to be monitored during the operation of the equipment. We have flow meters for both modules individually monitored and controlled. And then we have adjustment valves for each module. So this system is designed to run actually at 7 gallons a minute or 14 gallons a minute. You can run one module and make 7, either module, or you can run both modules and make 14. And regardless of whether you run one or both, the gauges and the flow meters are assigned to each module individually. We have, you'll notice also on the inlet, we have a safety pre-filter. This is a 1 micron absolute rated filter to catch any sediment or other particles that might have been picked up if the reverse osmosis feed water had been in a tank or in any other place. We monitor the pressure across this filter as well, and those pressures are displayed on the gauges. Here, pre-filter inlet, pre-filter outlet. Then we monitor the pressures into the EDI module and then out of the EDI module. So we have module 1 feed, module 1 concentrate, module 2 feed, module 2 concentrate. Then we have a combined permeate or product water out pressure and a concentrate outlet pressure. We recommend you try to minimize the back pressure on both of these outlets here and let it to the atmosphere or to atmospheric tank or to atmospheric drain, so you don't get a lot of back pressure on either the concentrate or the product outlet. You'll see there's 3 flow meters for each module. Again, we have 3 streams. We have a concentrate stream, product stream, electrolyte stream. The concentrate for each module should be about 1/2 gallon a minute, or roughly 2 liters a minute. The electrolyte should be about 300 milliliters per minute. And the product flow can be adjusted, but it's designed for 7 gallons a minute. You can run it lower. If you run it higher than 7 gallons a minute, it will make more than 7, but you'll have to regenerate the module more frequently. So we recommend that you run about 7 gallons a minute. Keep the concentrate. You can adjust this knob to get the flow exactly where you want, about 1/2 gallon a minute, and you adjust this knob on the electrolyte to get it about 300 to 400 milliliters per minute. Same goes for module 2. The way you adjust the product flow is using this red valve right here. If you open it, product flow will increase on this flow meter. If you close it, product flow will decrease on this flow meter. Important thing to remember is if you adjust this valve, the flows will, all 3 flows will change. If you open this valve, the concentrate and electrolyte flows will drop, so you'll have to open those up balanced. So anytime you adjust one, you're probably going to have to adjust all 3. These 5 valves on the front are just samples. So you can sample the quality of the water at the inlet to the system, the concentrate out, each module individually, and then the final product out. Right. So that's all the instrumentation of the system. I'll tell you about the operation of the system. You'll see here, there's 4 instruments here. First, these are instruments that monitor the quality of the water being produced. This one is a conductivity and resistivity meter. It has 2 displays. There's actually 2 conductivity readings. One is a feed conductivity into the system. One is the product resistivity out. So you should see the first number will be measured or displayed in microsiemens. The resistivity will be displayed in megohms of resistivity. You'll see little red lights. You can see the red light right here. If one of these red lights is illuminated, that means there's a fault condition. Either the feed conductivity is too high or the product resistivity is too low. We're not running the system right now, so the product resistivity is low, hence the red light is on. The second meter is a product pH meter. It measures the pH of the EDI product water being produced. No control, no alarms, it's just for display purposes only. These 2 instruments are the control modules for the individual power supply. These will display the volts and the amp draw for the power supply that feeds the EDI module. The voltage will typically be adjusted using this knob, and it should be adjusted to about, during normal operation, about 200 volts. The maximum voltage of the power supply on a 380 volt power supply, which this is designed for, is 340 volts DC. Control modules display voltage from the power supply to the EDI module, and then the amp in the current load across the module displayed in amperes. Under normal operation, the voltage should be about 200 volts. The amperes will be typically 2 to 3 amps, sometimes more, sometimes less. During regeneration, you can increase the voltage. It'll go as high as 340 volts DC, and the amps can actually go as high as 10. If you get above 10 amps of actual load across the module, the power supply will not be able to handle more than that, so the voltage will have to drop accordingly, and it will drop until the module is regenerated. The complete regeneration procedure is described in our operation manual. But for summary to operate the equipment, you're just going to adjust this knob until you see 200 volts, and then you leave it alone, and you will then see what the amp load is across the module. And you'll do this for both modules. These lights and switches are used to operate the equipment. The first switch is to power on. Right now we're bypassing this switch for demonstration purposes. These 3 switches control the operation of the equipment. This one turns the whole system on. If I put it in hand, the system will come on and power up. If I put it in auto, it will run if the level controls in the customer's tank, storage tank, indicates that it should run. Now let's put it on hand. Once it's in hand or auto, you can run each module individually. If this is an off auto switch, so if you put it in auto position, then module 1 will try to run. You put this in, module 2 will try to run. You can run either module individually or both at the same time. Now you see we have a couple of alarms here. We're not running the system right now, so there's no water going through the system, so we're getting 2 alarm conditions. There's two safety switches on the system. One is an inlet flow to make sure we have enough flow coming into the system, and one is electrolyte flow, which makes sure we have enough electrolyte flow to each module. So this one is the electrolyte low flow alarm. If we don't have enough flow to the modules, right now we don't have any, you'll get this alarm. If we don't have any flow into the total system, you'll get the low enough flow alarm. Right now we have no flow, so we get both alarms. If you want to clear the alarms and restart the system, press reset. Lights go out, system will try to start again. It'll wait 10 seconds. If it doesn't have if it has no alarms after 10 seconds, power supplies will start and the system will produce purified water. If you don't, if you do have an alarm condition after 10 seconds, then the lights will come on and it will stop. Here the solenoid comes on, should wait 8 seconds, and then if you have an alarm condition, the light comes on. Other alarms are if we have a fault on the power supply you'll get these two lights, either one. This alarm and this alarm are for the feed water and product water conditions. As I mentioned earlier, you have one of these lights up here that indicates a high feed TDS condition or a low product resistivity condition. These lights will illuminate. And then the final indicator are the blue and the yellow. The yellow is a pre-treatment lockout, so if you have a reverse osmosis system or some other equipment in front of this system and you want this EDI system to stop when that system stops, you can make that connection internal to the control panel. When that pre-treating system stops, this light will come on, the system will stop. When the pre-treating system starts again, the light will come back on, or go back off, excuse me. And the blue light is indicating the product water storage tank. If you have a storage tank, level control, when that tank's full, stopping this system, the blue light will be on. When the light is off, the tank is not full, the system can run, that light will be off. So those are all indicator lights. And then we have emergency stop. If for some reason you need to stop the system right away and cut power to the panel, hit that button, and that'll stop all power to the system. To restart is twisting.